a bit not at 9th standard level, it's 11th standard portion. I'll just try to see how we are able to follow. Okay.
Yes, sir.
So, what do you understand by projectile? First, in the 1D motion, we got 3 equations of motion, right?
Sorry?
In 1D motion, one-dimensional motion, we have 3 equations of motion.
Okay.
V equal to u plus at. You remember them?
Yes, sir.
And the second one is what? Second equation is equal to ut plus half at square.
Yes.
And the third one is
2a
v square equal to
u square minus 2a.
plus 2as. Okay, so that is for 1D motion. Okay, so what do you understand by projectile motion? Any idea?
No, sir.
Okay, this is the Earth's surface. If I throw a ball vertically up, it goes and comes down, right?
Yes.
So this is a 1D motion or 2D motion?
2.
No, it's just going up. So if x-axis is this way and y-axis is vertically up, so only the y of the mass changes, right? X is same.
Yes.
So it is a 1D motion or 2D motion?
1D.
1D if it is thrown vertically up. Okay. Now instead of throwing vertically up, I'll project it with an angle. I throw with an angle. The initial velocity is u, and it's making an angle theta with the Earth's surface. Okay. Now this thing will move something like this. Okay. So this motion, the blue line, it's 1D motion or 2D motion?
This is 2D because both the things are changing.
Yeah, x is increasing and y is also increasing and decreasing, right? So both
Yes.
are involved. In this vertically thrown case, x is constant. Okay. So this is a 2D motion. So this motion
2D.
where the body is being projected with a velocity, which makes an angle theta, is called projectile motion. So because of vertically upward motion, what is the value of theta? Theta is the initial velocity angle
Yes.
with the horizontal. So because of vertically moving upwards, what is theta? Is that clear?
Yes, sir.
But I'm just going vertically up with this angle. This angle is 90 degrees. Okay.
Yes.
Okay. So this is projected from the Earth's surface. And there's one more thing I can do. I can project it horizontally. So what is in the horizontal projection? It should be thrown like this with the horizontal velocity. Okay. In this case, theta is how much? Yes.
180.
Yeah, 0 degrees. So it will move like this, right? And this is the Earth's surface. So the thing is, this should be thrown from a height. From the Earth's surface, if you throw it, it will not. It will go along the Earth's surface. So initially there has to be some height from which you throw. Okay. Here that height is not required. You can throw from the ground itself. You get the difference, right? But horizontal
Yes,
projection,
sir.
I need to throw from a height. Okay. And third case is projected from a height. Instead of having theta equal to 0, So here there is some value of theta. Okay, difference between this and the first one is here the initial y is at some h. Here initial y is 0. This is y equal to 0, right? But here the initial y is some value h. So that is the difference between projected from a height and projected from ground. Okay, so these are the different types of projectile motions we can have. One is from the earth at an angle theta, and second one is horizontal projection, that will be from a height. And the third thing is from a height we can project it at an angle. Okay, so all these three are motion. So projectile motion in general is a 2D motion. Vertically curved motion is a special case of projectile motion. That is not referred as projectile motion. So by projectile motion, we understand that it is a 2D motion. Okay. An object in field after being thrown or projected an angle from Earth's surface is projectile motion. Okay. Earth's gravity along negative y direction and motion of the plane is xy. So Earth's gravity is downwards, right? Because
Yes.
Earth is here. Okay, and yes, this is a 2D motion. 2D motion means it's in a plane. It's in a single plane. Okay, suppose XY axis is in the plane of the paper. Okay, so the thing will move in that plane only. It will not leave that plane. Okay, the 2D motion can be broken down into two separate, simultaneously occurring components of motion. Okay, because we know how to handle 1D motion, we have the three equations of motion, right? So this 2D motion can be thought of as two separate 1D motion. 2D motion is equivalent to two 1D motions. Okay, and the two 1D motions are one is x and another one is y. Right? We can split the motion into parts. One is along the x direction, that will become a 1D motion. Another one, if I break it into y motion, that will be considered as a 1D motion in the y direction. Now let us see how this breaking up can be done. Okay, Galileo is the first one to say that this can be split into two components and they can be combined later. Independency of horizontal and vertical components. Okay, independent in the sense for the sake of analysis, we can consider them as independent, but in the end, we can combine them to get the final answer. Okay, and in the x component motion, is there any acceleration?
No.
This is x-axis. This is y-axis. Okay. Direction of Earth's gravity is downwards, g. So in this direction, is there any acceleration? No. What about in y direction?
Yes, because it goes up and then it comes down.
So that acceleration is g, and the direction of acceleration is minus j cap. You know what is j cap? Cap indicates unit vector. You know what's a unit vector?
No.
You know what's a vector?
Yes.
It has got direction, right?
Yes. And magnitude.
Yeah. But unit vector has got a direction, but the magnitude is 1. So it just gives us the direction information. So the j cap direction is this one, vertically upwards, and its length is 1. Okay, so minus j cap is downwards. If you take a vector A, the vector minus A direction is opposite of A. So j cap is a unit vector denoting the direction of upwards. But since g is downwards, I can use minus j cap. Minus j cap is a vector which is downwards. So the acceleration is minus g j cap. Is that clear?
Yes, sir.
Magnitude is g and the direction is minus j. Right. So the vertical component motion is a uniform acceleration motion. The horizontal motion is a uniform velocity motion. Okay. So now we are projecting an angle. So the initial velocity in the horizontal direction this is u, and it's making angle theta with the earth. Okay, and this is my x-axis, and y-axis is like this. Actually, the origin of x and y are here. So this is 0, 0.
Yes.
Okay. So what is initial velocity in the x direction? Like you know how to split a vector into components, right? Use a velocity vector. So if you split into two components, this horizontal component will be how much? U cos theta. You know that thing? How to split a vector into components? If I have a vector A and this is making angle theta here, okay, what will be this length? Vector A is this length is A, right? Vector has a
Yes.
vector has got length A and direction as this one. So this, what about this length then? The horizontal, this length is how much? Be A cos theta.
Okay.
That's because you take cos theta is adjacent side by hypotenuse. Hypotenuse is A. So from that you get adjacent side as A cos theta. So similarly, what is the vertical length?
A is sin theta.
Yeah. So this A vector has been split into two components. So you can write A vector.
Opposite side.
Yeah. So you can write A vector as A cos theta I cap plus A sin theta j cap. You know triangle law of addition of vectors, no?
Sorry.
Triangle law of addition of vectors. Okay, we are going from this point to this point. So this is one point, and this is a final point. The vector is connecting these 2 points, right? Instead of going this one to this point this way, I can also go this way.
Yes.
Okay, so those 2 ways should give me the same result. So A vector is A cos theta and I cap in the horizontal direction, then A sin theta and j cap in the vertical direction. Okay, and just accept this result. Okay, so similarly, U is a vector, velocity vector. So in the horizontal direction is U cos theta, and in the vertical direction it is U sin theta. Okay, and in the x direction it's a uniform velocity motion, right? There is no acceleration.
Yes.
So if you use that x equal to ut plus half at square, a is 0, so you get x equal to ut, right? You have that equation, right? X equal to ut plus half at square.
Yes.
In that a is 0 for the horizontal direction, so you get s equal to ut, right? And that this is what is written here. This one, x equal to u into t, where u is the horizontal component, u cos theta into t. So this is clear for the horizontal motion, uniform velocity. This is okay, right?
Yes.
So in the vertical direction, this is the equation. Can you figure that out?
Yes.
is equal to ut plus half at square, and u is u sine theta in the vertical direction, and a is minus g because it's along the negative y direction, right? Yeah.
Yes, sir.
Okay. Now at this topmost point, if I draw a tangent to be horizontal, what is the value of at this particular point? What is vx and what is vy? What is x component velocity? X component, there is no constant speed motion, right? So whatever is the initial thing, it should be the same thing. In the x direction, the velocity is not changing. So whatever is the initial velocity u cos theta, it should be maintained throughout. Okay. And what about vy? This is the maximum point. Okay. Initially, there is some value of vy. After that, it will increase or decrease when it moves up. Vy, will it increase or decrease when it moves up? When you throw your ball vertically up, its speed keeps on decreasing or increasing or
It keeps
constant.
increasing.
No, when you throw from ground, if it keeps on increasing, it will not return, right? When you throw an object up, it goes up and comes down, right?
Yes.
If it keeps on increasing, it will keep going on.
Yeah.
So it is decreasing. And at the point where it is turning back, the direction of velocity is changing, right?
Yes.
So at the turning point, turning back point, the velocity is 0. Okay. So here if you take this maximum height point, just below this, it is moving up. Okay. Then just after this point, it is moving down.
It's going
Okay.
down. Yeah.
So at this point, the vertical component of velocity is 0. Okay.
Yes, sir.
So if I will use this equation v equal to u plus 18. I can use that equation at anywhere where the acceleration is constant. Okay. And I'll use it at this point. V is my velocity at the maximum height point. So v is 0 at that point, at maximum height point. Okay. And the initial velocity is u sine theta, right? This one. Okay. And acceleration is minus g. Okay. And the time taken to go from ground, the maximum height point is total time divided by 2. It is symmetric between about this maximum height point. Okay. So whatever, if it takes 10 seconds to go from here to here, it will take another 10 seconds to go from here to here by symmetry.
Yes.
Okay. If the total time is capital T, then the time taken to go from here to here is T by 2. Okay. Where T is the total time of flight. Capital T is the total time of flight. So the time taken for the velocity to change from 0, u sine theta to 0 is T by 2. So that's why that for T I put capital T by 2. Is that clear? This one?
Yes.
Okay. So from that we can get capital T as 2 times u sine theta by g. What is capital T?
Total time.
Yeah, time taken to go from sorry, time taken to go from here to here. Okay. That depends on the vertical component of the velocity, 2 sine theta divided by g. And the time taken to go from the origin to the maximum height point is how much? Half of that. Okay. So u is the initial velocity that will be known. Theta is the initial inclination that also will be known, and g is constant, that's also known. So the total time of flight can be known given the initial velocity and the direction. That makes sense, right? Okay.
Yes, sir.
Next thing is to find how far it has traveled in the horizontal direction. This total distance is called range. This total distance is called range, say capital R. So what is the coordinate of this point? What is the value of x at this point? This is x equal to 0. So what will be the value of x here? This distance is R, range. X will be R, right? And y is 0. Because on the x-axis. Okay, so now what I want to find is this distance, capital R. How do you find the distance? What is the velocity in the horizontal direction?
Use.
U cos theta, right?
Yes.
And it is constant throughout. Horizontal velocity is not changing. Okay, and the time taken to cover this distance R is capital T. We found out here, right? Okay,
Yes.
so if I take U cos theta and multiply with this capital T, I'll get R. Yes?
Yes.
Velocity into the time, right? So that's what range is, the horizontal component of the velocity U cos theta into the time, and capital T we have found out here, 2 u sin theta by g, that I'll use here. So it will become 2 u square sin theta cos theta by g. Okay, so it is u square by g into 2 times sin theta cos theta. So there is one identity. If you don't know, you just accept this identity. You can prove it later. 2 sin theta cos theta equal to sin 2 theta. Like for example, 2 sin 30 cos 30 equal to sin 60. You might have in the maths this thing I told you the values how to get it, right? Sin 30 is half,
Yeah.
cos 30 is root 3 by 2. Okay, so this is uh, root 3 by 2, and sin 60 is root 3 by 2. Okay, so this is true for this particular example, but this is a general result. 2 times sin theta cos theta equal to sin theta. You just accept this one, you will learn it later why that is true. So the range is u square sin 2 theta by g. U is the initial velocity which is known, and theta is the initial velocity that will also be known. The range is known. Okay. Right. Now we have got the maximum height. Sorry, the time taken the thing to go from 0 to capital R, and then the range also. Okay. X equal to u cos theta into t, and y equal to u this one. There are two equations, right? And then x. Okay, you can eliminate t from them. If you eliminate t, then you get a relation between y and x. Here, what are the variables? X, t, y, and t, right? So x, y, t, independent variables. Okay, so you can eliminate t. From the first one, you get t as x by u cos theta. It's clear, no? X equal to u cos theta t. From that, we'll get t as x by u cos theta. That t you can put it here, the second one, and then if you simplify it, you'll get y as this one. Should I do the calculation? See, second one is y equal to u sin theta into t. Instead of t, I put x by u cos theta. from the first equation. Okay, and then minus half g t square. T square is x square by u square cos square theta. Okay, so this will become tan theta into x minus half g by u square cos square theta x square. Second term is just I'm just keeping it. That's what is written here, right? So now we have a relation between y and x. Time is being eliminated. So how will the plot of this curve look?
Sorry.
Is a plot y versus x here. This relation, this function, if I try to plot it, how will it look? You have any idea? You know equation of straight line, right? What is the equation of straight line? Y equal to? Is that right?
Yes.
Similarly, if I write an equation like this, y equal to ax square plus bx plus c. This is called parabola. This is the next higher complication, right? The first one is just x and constant. M and C are constant, so x and constant, that is here, and x and constant. Now we are adding this extra term, which is quadratic and square in x. Okay, so this when you add this thing, this equation becomes a parabola. Okay, here also we have x square here. This is the x square term, and we have x term here, and the constant c is 0. This constant c in this particular case is 0. Right? We can also have equation of line as y equal to mx, like passing through origin. Similarly, we can have parabola with the constant 0. So this is the equation of parabola, and it would look like this. So this is a parabola.
What does parabola mean, sir?
See, equation of straight line is this one, right? So similarly, the equation of parabola is this one. So the parabola, if I try to plot it, it will look like this, like U, or it will look like this inverted U. Like straight line, it can be like this, or like this, or like this, or it can be like this, right?
Yes.
Okay, and these are positive slopes, and these are negative slopes, and
Yes.
the one which is passing through origin is y equal to mx, where c is 0. So all those properties are there, right? Even for parabola, you can have either U or inverted U. When it is U, A will be positive. When it is inverted U, A will be negative, less than 0. Here A is negative. A is this plus this and this combination. So A is negative because of the minus sign. Since A is negative, it is inverted parabola. So it is this portion of the parabola from here to here. Because below this is the ground, it will not proceed further. So wherever it is traveling, it will be in form of parabola. And so this is the parabolic curve. That's why I've said the trajectory. Trajectory means the path of the mass. Trajectory is parabolic. Okay, if you're not understanding fully, it's fine. You will understand it as you go along. This is actually 11th standard portion. So if you don't understand anything fully, it's okay. Just accept these things. It will become clear later. Okay.
Yes, sir.
But the basic idea is it's a 2D motion which is being split into two 1D motions. And you know how to handle 1D motions because you already have those equations. V equal to U plus 80 and those three equations. So those three equations now we are applying to both x and y. For example, this one. The same equation x equal to U plus half a t square, you apply for x and y. Right? And then you can combine them later. Okay. To get the maximum height, okay, you will take, okay, you can take this equation x equal
Yes, 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 yes.
Actually, the three equations are there, right? You can add one more equation. X equal to dt minus half at square. You also have s equal to ut plus half
Yes.
at square. You can have this as the fourth equation. Okay.
Okay.
In this one, if you put s as h, so that is a from here to here, this point to this point. Okay. The distance traveled is h, and then the velocity at this point is 0, final velocity. So that's why the first term is going away, and then it's half at square, right? And a is minus g. So that's why it has become plus. And then t is we already found out. T is the capital T by 2 because t is the time from here to here. It is half the thing. So this time is the total time divided by 2. And total time we have found out earlier is 2 times u sin theta by g. So half time will be u sin theta by g. Okay. So now we can simplify this one. So you get as u sin theta square divided by 2g. So the initial velocity is known and the angle with which it's thrown is known. Then the maximum height will reach is known. This distance is h. Okay, there is another way of getting this answer. That is by using b square equal to u square plus b is 0, this one at the maximum height point, and u is u sin theta. It's a vertical component, and a is minus g, minus 2g, and s is h. So from this I get h as u sin theta square divided by 2g. That's the same result. Is that clear?
Yes, yes.
U sin theta is the one that's going to come here. And write it again. Okay. Right. Similarly, we can do the same thing for the case of horizontal projection. In this case, theta was some value, right?
Yeah.
In this beginning equation, if I put theta equal to 0, I'll get those two equations. I'll get x equal to ut and y is minus half dt square, because theta 0 means cos 0 is 1 and sin 0 is 0. So my x will become u into t. Okay. This is the height h is projected. Okay. And this is the at any time t, the value of x is u into t. And similarly, y is ut u sin theta into t. U sin theta is 0. So minus half g t square. So at this point, if it had taken a time t to reach this point, the x coordinate will be ut and then y coordinate is minus half g t square. Minus because I am taking this as my origin. This is my x and this is y. And this is origin 0, 0. So obviously y is negative, right, at this point. That's why it's minus half gt square, the y coordinate. Okay. So similarly for this thing, projected from a height, that depends on again where I choose my coordinates. It's projected here. So I choose my xy like this. This is origin. Okay, so again x equal to there is some theta. Okay, right. The difference between this, okay, in this case, the height is maximum height is this, right? Maximum height point. Okay, here in this case, the time taken to go from here to here and the time taken to go from here to here, are they same?
No.
This is the earth level. Okay, the time taken is not same. Okay, because this is starting from height. So that's the important
Yes.
difference here. But still you can write the same component equations and solve the problem. Yeah, this one projectile motion. Okay, that's what is
Yes.
been thrown at an angle. And acceleration is minus g j cap. Okay. So from the picture you can see the length of the horizontal vector. The length is always same at the beginning point, at the middle point, at the topmost point, again at this point. Again, if you see the horizontal length of the velocity component, it's always same, right? But if you see y, it's long here, it's short here, it has become 0 here, and it's become uh, again a little bit longer, but the direction has changed. And here it has become longest, but the direction is opposite to what is there as starting point. Understand the picture?
Yes, sir.
Among the two components, horizontal component size is same throughout. Vertical components decreasing, becoming 0, and then changing its direction, and then increasing. Okay, let's try this simple problem. Example, you have pen and paper.
Yes, sir.
Let's try this out. Thirty degrees. Maximum height. Time taken with the ball to return to the same level, and then distance from thrower to the point where the ball returns. Understood the problem?
Yes, sir.
So it is thrown at 28 meter per second, and this angle is 30 degrees. Okay, right, that's all you need, right? Initial condition is the velocity with which it's thrown and the angle with which it's thrown. Once that is known, everything else is known. Right? How do you find maximum height?
Mm,
We already derived it. So first thing is we can calculate the time to reach the maximum height. The maximum
sorry.
height, at the maximum height. See, if you know the time taken to reach the maximum height,
Yes.
okay. After that we can use s equal to vt minus. We can use this in s equal to vt minus half a t square. At the maximum height point, velocity is 0. Okay, acceleration is known, and if I know the time taken for the thing to go from ground to the maximum height, I can find H, right? S is from ground to maximum height point, so S will become H. Okay, and the final velocity is 0. Okay, acceleration is minus g, and T is capital T by 2 because it's a time go from 0 to maximum height. It's the half of total time. Okay, so I just have to find the capital T, and to find capital T, I'll use this V equal to U plus AT. V is 0, U is known, and then acceleration is minus g, and time is capital T by 2. Right, and U is the vertical component, Uy. Everything is vertical motion, right? So capital T by 2 is U sine theta by g, and U is how much? 28. Sine theta is sine 30, it's half divided by g. Let it be g only. So it is 14 by g. So it is okay. Here there is one minus, and this will cancel this minus. So it is half g into T by 2 is 14 by g square. So it is 14 square half into 14 square by g. That is the maximum height. That's what it is there. 14 square by 2g. That's what I got, right? 14 square by 2g.
Yes.
So we understood the steps, right? See,
Yes.
time taken to reach the maximum height point, I can get the S equal to Vt minus half Vt square. Acceleration is minus g, so the whole thing will become plus. So this T is capital T by 2. To get it capital T by 2, I'll use V equal to U plus AT in the vertical direction. So I get this one. Okay. And the next one is time taken the ball to return the same level. That is range, right?
Yes.
Range is the horizontal velocity ux into capital T, because ux is same as vx. Because the horizontal direction, there is no change in. So it is u cos 30 into capital T we have found out here 2 times. So it will be 28 by g.
Yes.
T by 2 is 14 by g. The capital T is 28 by g. And u is 28, right? 28 into root 3 by 2. 28 by g. So 28 square root 3 by 2 by g. 28 square root 3 by 2 by g. Sin 60 is root 3 by 2. Yes, no? 28 square by g into sin 60. 28 square by g. Sin 60 is root 3 by 2. Correct, no?
Yes, sir.
This is sin 60. And then it's 28 square by g. 28 square by g and sin 60. And distance from the thrower. C is range. Okay, B is the total time. Okay, the second part B is capital T. Capital T is 28 by G. Capital T is 28 by G. Okay, and this is the third part. So this book is there. You look at the examples, and you can also read the theory part. It's well written.
Yes.
So
Yes.
look at the example and don't hide the solution and try to solve the problem. Okay, and after that you look at the solution if you don't get it.
Yes.
Okay. Yeah, there are a lot of things which you may not understand right now. So just look at the portion. I send you the PDF. Just look at the portions which I have covered. Okay, there are scalars and vectors. Don't look because you might have some idea. So try to read it. If you are understanding, proceed. Otherwise, just stop it.
Okay,
Okay.
sir.
Multiplication vectors only is new. You may not understand now. Just leave it. So just go to this projectile motion.
Okay, sir.
4.10.
Yes, sir.